Hello, I welcome you all to this wonderful lesson. And in this particular lesson, this is a question that we are having under physics. This is one of the important questions that don't miss. So even as we get to revise these wonderful questions, I want you to follow me clearly. I want you to follow each and every word that I'm going to say so that you don't miss anything in an exam. Those of you that are under my online lessons, make sure that you write down these questions. Make sure that you write them down in your books for proper revisions, because you might not be able to check out for this video. So it is better you just write them down in your book even as you get to revise. So this is radioactivity. All the questions here are falling under radioactivity. So this whole topic is just radioactivity. We are just talking about radioactivity. So I want you to follow me very well. I want you to follow me closely, even as I teach you this important topic. I believe we've all joined in. You've joined in. So this is the topic that we are doing. So let me say solutions. We start answering these particular questions. So solutions. So since these questions are falling under radioactivity, and there is something important that you need to note, there is something important that you need to understand. You need to know what radioactivity is. So we need to know what radioactivity is. So the question is saying the nucleon number of that particular element is 218. What is meant by nucleon number? And this other question is saying that one decays by radioactive decay. So these questions, all of them are falling under radioactivity. So you need to know what radioactivity is before going any further. So each time we get to talk of radioactivity in an exam or when you are studying, you need to know that radioactivity is a spontaneous breakdown of any unstable nuclei emitting three important things. If an unstable nuclei breaks down and emits, it is going to emit, and now it is going to emit either one of these three things: an alpha particle or a beta particle or a gamma ray. So when an unstable nuclei breaks down like that, it is going to emit either an alpha particle or a beta particle or a gamma ray. So there is what we call radioactive decay that enables us to understand what it is emitting, what are some of the characteristics, what are some of the properties that will make you understand that this one is breaking down and it is emitting an alpha particle. What are those things? So there is radioactive decay that helps us. So even as I get to teach you this topic, I will not only teach you how to answer these questions, but these questions should open up your mind even to understand other questions. So even as we continue, make sure you've liked the video, make sure that you are sharing to other people. And we are going to solve these questions together. We are solving these questions together. This is School at 5 that was brought by reason of helping my online students catch up. So this program, I introduced this program because of the people that I'm teaching online, more especially the people that joined me late. This is the whole reason we are doing this. And even people that are not under my online lessons at 05, they are also benefiting. So I'm not only helping the people that I'm mentoring, but even the people that can't manage to join my online lessons. But if you can, make sure that you join me. It's only 100 kwacha, both chemistry and physics. If you're paying for mathematics, it is also 100 kwacha. So we go into the questions. The first question is saying the nucleon number of PO, that is a particle, is 218. So we are given that one, that is PO, it is what? 218. 218 and 84, like that. This is a particle that we are given. The first question is saying, what is meant by nucleon number? What is meant by nucleon number? So you discover that physics and chemistry, somehow they are related. So what is meant? So when you look at an atom is like this. This is how an atom is. I've said that these are revisions, so I've started here now. I've started. So I want your participation. So you discover that on top here, we get to have A. And down here, we get to have what? Z. So what is found on top is the mass number. This is the mass number. So this is the mass number. What is down is called the proton number. The Z is the what? The proton number. So these, they are not like this, but they are special names. They have got their alternative name. So their alternative name for a mass number is called nucleon number. This is the alternative name of what? Mass number. It is called what? Nucleon number. So mass number and the nucleon number, they are just the same. Now, what is the alternative name for proton number? What is the alternative name for proton number? Let me see the people that are participating now. What is the other name for proton number? What is the other name for proton number? What is the other name for proton number? Let me see answers. Let me see answers. What is the other name for proton number? What is the other name for proton number? The other name for proton number, let me see people participating. Let me see people participating. I can't see your comments here. What is the other name for proton number now? What is the other name for proton number? We are devising together. I'm helping you answer these questions. You are the one who's supposed to answer them. You are the one who is supposed to answer them. Okay, I can see two people. Atomic. Yeah, that is so good. So, atomic number. Okay, yeah, this is so good. So, you are the one that is answering these questions. I'm just helping you. Me, I'm just giving you ideas how to go about it. What about atomic number? Okay, this is so good. So, myself, I'm not even supposed to answer these questions. You are the one who is giving me answers. So you've told me that this is the what? This is the atomic number. I can see people have commented. This is good. This is atomic what? Atomic number. The other name for proton number is called what? Is called the atomic number. So I want you to participate fully. I told you that if you are using Facebook Lite, it is difficult to type. So we need to download the original Facebook so that even as you are participating, you're just participating like that. Okay, watching the video. If I ask a question, you just type. It's very easy. I find it easy to participate on a live if you are using the actual Facebook, not a Facebook Lite. So now the question is saying, what is meant by nucleon number? So nucleon number is just the same as telling you what is meant by mass number. It is just the same. So what is meant by mass number? What is mass number? So mass number or nucleon number, it is just the same. So what you need to know is that if this is the nucleus and these are shells, so these are shells. In shells, we get to find electrons. We've got electrons there. This is where we get to find electrons. So inside the nucleus, we find the protons and the what? And the neutrons. So this is the nucleus. In the nucleus there, this is where we get to find the what? The protons and the neutrons. So if I ask you that what is meant by nucleon number, this is just the total number. Is that the total number? The total number, this is just the total number of what? Total number of protons and what? Neutrons in the nucleus of an atom. Neutrons in the nucleus of an atom. In the what? in the nucleus of an atom. This is what you need to understand. Have you seen? This is what you need to get. So mass number or neutron number, it is just the total number of protons and neutrons in the nucleus of an atom. This is what we get to talk about. So make sure you share the video. Make sure that you like the video. So this is what you need to do. We are done with that particular question. Just like this, we've answered it. Now, we move to this one that is here, that is saying, this is a particle given. Have you seen? They're saying this particle you are given, it is having a what? It is having mass number there, 218. Then it is having proton number, 84. Decay by radioactive decay. It is going to decay by radioactive decay. The first question is saying, what is meant by radioactive decay? So what is radioactive decay? The people that know, I'm going to give you 50 seconds to type radioactive decay. If there is one that knows, what is radioactive decay? What is radioactive decay? So what is radioactive decay? If there is someone that knows what is radioactive decay, just give it a try. What is radioactive decay? So what is radioactive decay? Just to simplify things, so you can just type in 50 seconds. I've given you 50 seconds to participate. Okay, maybe let me answer this because of time. I can see typing these things, we can consume a lot of time. So unless those ones that one word answers are the ones that I'll be giving you. So let me help you this. Let me help you. So radioactive decay is a spontaneous breakdown of an unstable nuclide to emit alpha. So radioactive decay. When I say radioactive element, this is an element that undergo what? Radioactivity. Now radioactive decay is the spontaneous. This is the spontaneous. So is the spontaneous breakdown. So this is a spontaneous breakdown by emission. So by emission of an alpha particle, by emission of alpha and beta particle. So beta particle and gamma radiations. This is what you need to understand. So we're just talking about emission of what? Emission of an alpha and beta particles and gamma rays. So when an unstable nuclei, when the nucleus, which is not stable, breaks down, so the moment it just breaks down, you need to know that these things here will do what? Whenever it just breaks down like that, you need to know that we are going to have one of these things, an alpha particle, a beta particle, or a gamma ray. This is what you need to know and understand. So an alpha particle and beta particles, these are independent topics that we get to study them on their own. You know that an alpha particle, this is a positive charged particle, and a beta particle, this is a negative charged particle. And by nature, an alpha particle is the helium nucleus. This is what you need to know and understand. Okay, so I can see what's an alpha and beta particle is the emission of particle from an unstable element to form a stable nucleus. So I've tried. Yeah. So this one, this is so good. This is so good. So when it breaks down, it is not forming a stable nucleus. That same nucleus can also break down because it is a radioactive decay. It just breaks down. When it is like this, breaks down, it will just keep on breaking down. We know that this gets to happen with elements on the periodic table with atomic number greater than 82 on the periodic table. So these ones now, an alpha particle, this is an helium nucleus. A beta particle is an electron. A gamma ray, this is an electromagnetic wave. So this is what you need to understand. So these are some of the things that you need to get. These are some of the things that you need to understand. So now we go to the next question. Let us go to the next question. State the atomic number, and so I'm on this question. State the atomic number and neutron number of the daughter nucleus left after an alpha particle is emitted from this nucleus. This is a wonderful question that you are given. Let me write it here. This is a wonderful question that you are given. So you are given this question. Before you get to answer this question, there are certain things that you need to know. There are certain things that you need to understand. We are now talking about what? Radioactive decay. We are talking about radioactive decay. So you need to know what we get to mean when we say radioactive decay. I've given you the what? I've given you the formulas. So now I've given you the definition. So there is what we call alpha decay. Before we know that we are revising through these things. So there is what we call an alpha decay. There is what we call a beta decay. There is what we call a gamma ray decay. So these are the radioactive decays that you are supposed to know. This is what you need to know. This is what you need to understand. I think this is clear. You are able to see. I believe we are able to see. Even as we are watching this, don't forget to share. Don't forget to like the video. Okay, so an alpha decay. When we are talking about an alpha decay, what you need to understand is that in an alpha decay, we get to have the what? The mass number. You need to know the mass number will do what? What will happen to the mass number? And what will happen to the proton number? So we've got these two. So this one, we've established an understanding to say that an alpha particle, this is an helium nucleus. Helium which is like this. Helium which is like this. Helium is just like that. So what you need to know and understand is that when an unstable nucleus breaks down and emits an alpha particle, what will happen is that the mass number will reduce. The mass number will reduce by what? The mass number will reduce by 4. This is what you need to know. The mass number will reduce by what? It is going to reduce by 4. And the proton number will reduce by what? This one will reduce by what? By 2. The 2 that is there. So this is something that you need to know. This is something that you need to understand. So I can see the mass number will reduce by 4. This is so good to see that people are commenting. So we already know these things. We are just revising through. So we know that the mass number, if you are not able to see here, this mass number, this is, I've just written mass, but it is mass number reduced by 4, proton reduced by 2. This is what happens. And we are told that in here, we are given the what? We are given this radioactive element where it breaks down and emits an alpha particle. So it is emitting an alpha particle. So what is now, what is remaining? What is remaining? What is remaining on this? What is remaining? So maybe some of you are surprised today we have physics. There is something that I'm likely to do tomorrow in chemistry. So this is the reason why I've brought physics today. Tomorrow we are going to be revising through chemistry. So now, when it breaks down, let me write it. It is like this. PO Then we've got 84 down there. We also have 218 on top there. So this is what we are given. I don't know if people are able to see that. Are we able to see what I've written there? PO 84 218. Someone to confirm with me. Is that visible enough or it is too small? PO 84 218. Are you able to see that? Are you able to see or you're facing challenges? Is this clear there where I've written PO 84 218? Are you able to see? Someone to confirm? I just want to make sure that we are all able to see. We are able to see clearly. Are we able to see? Okay, sir, it is visible. It's good that we are able to see. So I thought that maybe this is too small. You can't see it. The focus of this gadget that I'm using now is not that much stable. So when it breaks down like this, what will happen is that you put a symbol here for an alpha. So that symbol there, it means it is emitting an alpha particle. So when it emits an alpha particle, a substance or an element that is formed, we don't know it. But we know that this one, the mass number will reduce by 4. So 218 minus 4. 218. What is 218 minus 4? Can someone tell me the proton number, the mass number there and the proton number? What proton number are we going to have? So what proton number are we going to have? What proton number are we going to have if the mass number reduces by 4 and the proton number reduces by 2? Tell me the proton number we are going to have and the mass number that we are going to form. So somebody to tell me the mass number we are going to have and the proton number that we are going to form. So you need to specify. You've said 214. So which one is which? You say mass number, if it is 214, you say mass number 214. You specify exactly. You say this is this. So what the mass number will remain what? And the proton number is going to remain what? What is the proton number and the mass number? You know that the mass number reduces by 4. The proton number is going to reduce by 2. You know that. So 82 proton number. Proton 218, okay. Mass number 214, proton 82. Mass 214, proton 82. This is so good that we are following. So this is so good. This is so great. So I can see, okay, we've understood this. So this now has been broken down. This is too simple now. People, so we can even finish this question. So this is so good to see that people already know these things. We are just revising through together. So this one reduces by 4. It becomes 214. This one reduces by 2. It becomes 82. Then you say plus. By nature, this is helium nucleus. You put the helium like that there. You put 2 there and 4. Some questions you will be taught to find the decay equation. So this is the decay equation. But in this question, they just want us to state the what? To state the atomic number and the nucleon number. So you already know the atomic number is what? Atomic number is 82. So the atomic number there is 82. We have the nucleon number. Nucleon number is just the same as mass number. Which is what? Nucleon number is what? 214. We've answered the question. So this is what we were taught to find. Like this, you are done. Sometimes you can be taught to find the decay equation. This is the decay equation that I've written here. So sometimes you can be taught to find the decay equation. So I've answered that. What if now, so what if the same particle that we are given, this element, now gets to emit a beta particle? What if it emits a beta particle? what will happen to the mass? Let me see the people that know. What will happen to the mass and what will happen to the proton number? So if it emits a beta particle, what will happen? Let me see answers. What will happen now? If that one emits a beta particle, what will happen? So that is beta decay now. What will happen? If it we know that we are revising through, so we must not be able to answer these exact questions, but these questions should open up our minds to other questions. We know how to go about other questions. So what will happen to the mass? What will happen to the proton number if it is emitting a beta particle? What will happen? So let us be quick on this. What will happen? What will happen? What will happen? I want to see your answers. What will happen? What will happen? What will happen? What will happen? Mass 218, proton 85. This is so good. This is so good. This is so good. This is so good. So you've just answered the question. That is so good. Mass number remains the same. Proton number increase by 1. This is so good. This is so good. People know these things. This is so good. This year we are breaking down science. We all need to get distinctions. With this old data that I'm seeing, we can't fail. So mass number is remaining the same. Proton number is increasing by 1. This is so good. This is so good. So you know that the mass number will do what? This one will remain the same. This one will remain the what? Will remain the same. But the proton number is going to do what? Is going to increase by 1. So if this was to undergo beta decay, it means that we are going to have PO 84 there and 218 there. So if it emits a beta particle, you put a symbol for beta like that. Then an element which is formed here, we don't know it, you just put X. The mass number remains the same. 218 is going to remain the same. Then the proton number increases by 1. So this one becomes 85. Then you say plus a beta particle. This is an electron. 0 there. Then this one negative 1 there. This is what you are supposed to do. So if you are taught to find the decay equation for a beta particle, this is what you are supposed to do. Just like that. So those of you that are under my online lessons, make sure that you are writing down these particular questions in your book. You need to have where you are writing down these questions so that at your own free time, you get to participate, you get to go through them. You are studying. So make sure that you are participating through. This program was introduced because of you. So let's make sure that we utilize this. We make sure that we write down these questions. And those of you that are not under my online lessons, we make sure that each and every question that we get to do together, you are revising through, you are writing down everything. So you just know that, okay, at 05 I get to have a class. So I'll be doing the necessary. So this is what we are supposed to do. This is what I want us to do. This is something that I want us to understand. So we are done with that. When we go to a gamma ray decay, this what will happen to the mass number? What will happen to the mass number and the proton number whenever we are talking about the gamma decay? What will happen to the mass number? And what will happen to the proton number? What will happen to the mass number and what will happen to the proton number? Let me see this. Let me see this. Sorry, sir. Mass 218. Okay, I get. So what will happen to the mass number and what will happen to the proton number? I want to see answers. What will happen? What will happen if it emits a gamma ray? What will happen? So if it emits a gamma ray, what will happen? I want to see your answers. I want to see your answers. I want to see your answers. What will happen? What will happen? Everything remain the same. This is so good. Everything will just remain the same. Another person, what do you think? What are your views? So I can see one person has said that everything will remain the same. What about others? What are you thinking? So we are revising through. Some people get to feel shy to give answers in class because they are thinking that my answer might be wrong. But with revisions, you just say, no matter the outcome, no matter what people think of you, you are just giving your opinions. Nothing changes. I can see another answer here that nothing changes. Okay, nothing changes. What about others? What will happen? So what you need to know is that when these things, when it emits, the mass number remains the same. Okay. Mass, no. Atomic, no. Atomic number. Okay, this is a mass number and atomic number remain the same. Okay. Mass number 218, proton 84. So it is just remaining the same. So everything automatically remains the same. This is what you need to know. So when it emits a beta particle, everything remain the what? Remain the same. Remain the same. Everything is going to remain the what? The same. Nothing is going to change. Nothing gets to change. So this is what you are supposed to know. This is what we need to understand. So we are done with this particular question. Let us now go to our last question. I give you time to prepare for work. I give you time now to, if there are people going to school, I give you time to do other activities. If you are studying, you do that. So let us go to this particular question. Below shows a graph for activity of radioactivity isotope whose mass is changing. This is a graph that is there. So there where you are, the whole essence is for you to understand this. Have you seen? So I've just written it like this so that you just understand, you get the concept. The most important thing is getting the concept. So the first question is saying, determine the half-life of the radioactive isotope. Determine the what? The half-life. The question that should be in your mind, what is half-life? So what is half-life? This is the first question that you should have. What is half-life? What is half-life? Just within 50 seconds, I want somebody to define what half-life is. What is half-life? What is half-life? What do we mean when we say this is half-life? What is half-life? What is half-life? What is half-life? What do we mean when we say half-life? What do we get to mean? What is half-life? What is half-life? Just keywords. You might not give the actual, like the whole definition, but like important words, keywords. What is half-life? 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 We are told to determine the half-life of the radioactive isotope. So now, what is half-life? What is half-life? What is half-life? We can't see the number. So, no, you might not be able to see the numbers. I've said that the concept here is just understand. This is 200 here. So I'm not telling you to determine the half-life on this. I want the definition. So this is 150, this is 100, this is 50, this is 0 there, this is 5, this is 10, this is 15, this is 20, this is 25. This is what is there. But I just want a definition. Time taken for any radioactive element to decay by half of its present material. I like this definition. This definition looks familiar. This is a definition that I get to give exactly like this. is the time taken for a radioactive to decay by half of its present life. Okay, this is so good. This is so good. This is so wonderful. This is so good. This is so good. This is so good. This is so wonderful. Okay, people know these things. We know these things. Okay, is the time taken for a radioactive to decay by its original mass? Is the time taken for a radioactive atom to lose half of its mass or concrete? Is the radioactive decay, is the radioactive time taken for it? I think the person that was typing this, you were too fast. I think so. You were too fast on this. Okay. So now, let me now give you the definition that I give myself. So someone just gave the actual definition that I give. Determine the half-life. Half-life is time taken for any radioactive substance to decay by half of its present material. So whenever we are talking about half-life, we are just talking about the time taken for that thing to decay by half of its present mass. So have you seen, we are given mass here. In this particular question, the question is saying, determine the half-life of the radioactive isotope. How can you determine the half-life? For you to determine the half-life, have you seen, time taken for it to decay by half of its present mass. So half of its present mass, where it is starting from, it is starting at what? It is starting at 200. So what is half of 200? 100, which is there. So concentration is on this part. Our concentration should be on this particular part. So what you are going to do from here, you draw a line like this. You hit the what? The curve like this. Once you hit the curve, then you go down like this. Myself, I'm rounding at what? I'm rounding at 10. So the half-life of this radioactive sample is 10 what? 10 years. I'm reaching at 10 years. So there it is what? 10 years. According to my graph. So according to your graph, what are you finding? According to your graph, that is 2A. Me, I'm finding 10 years. So the half-life is what? Is 10 years. According to the graph. The same way I've done like this. Those of you that are doing mathematics, you are able to agree with me that we get to do something like that in statistics. So you go where there is half of what you are given. Half of 200 is 100. You go at 100, you go towards straight. 200, 100, they're straight until you meet the curve. Whenever you just meet the curve, then you change the direction. You hit into that, don't penetrate through. Just that, then you go down there like that. So that you get the number that is there. According to this, it is falling at exactly what? At exactly 10. So this is 10 years. I'm already told that here there is what? These are years. There is years there. So I believe you've gotten the concept. Anyone that is behind on this, you just do this and that. You are done. So anyone that is behind, if you're writing these questions, you might not be able to get 10. Just approximate according to your graph. So if you've written down this, let me see what you're getting. If there are people that had to copy down this question, what answer are you getting yourself? Myself, I'm getting a 10 there, which you are even able to see. What answer are you getting yourself? What is your answer? What answer are you getting? What answer are you getting? If you are following, what answer are you getting yourself? Just me, it is 10. So 10 years. So my graph cannot be your graph. 10 years, you're also finding 10 years. This is so good. So this is so good. I can see one found 10 years. 10.3 years. This is so good. This is so good. So according to your graph, 15 years. I can't say that these answers are not correct. As long as I see the graph, then I will tell that, okay, this is 15. Okay. So I can see 15. Some people are finding 15. So you just give answers. 12 years. All these are correct. As long as If you say it is 15, so it moved and it went at 15. If you are saying this, you answer according to your graph, according to the graph. So this is just a sketch. I can see 12 years. So this is just a sketch that I was doing. This is just a sketch. Then let us go to the last question. So this is our last question. What mass of isotope will remain after 15 years? After what? After 15 years. So those of you that you found 15 now, this is where you get to find a challenge. So you're still going to have the same answer. Have you seen the same answer 100 because you're going at 15? But according to my graph, I'm going to go at 15. Have you seen? What mass of isotope will remain after 15 years? You go where 15 years is. 15 years is here. I do this. Then once I hit this cave, then I go that. What is there? 50 grams. So B, I'll just say 50 what? 50 grams. I'm done. According to my graph, I'm done. According to your graph, what are you getting? Me, I've gotten 50 grams. It is going at exactly 50 grams. According to your graph, what are you getting? According to your graph, what is your mass? What is the mass? According to your graph, what is the mass? What mass? What is the mass? According to your graph, what is the mass? Just according to your graph, what is the mass? Me, that is 50 grams. I think you've even seen how I was doing for me to answer this. The way I was moving. 15 there. I do this part. Then I start going. In an exam, you're supposed to be using a ruler. Mostly, you'll be given a graph there. So answers will come out exactly 75. Someone found 75, someone found 100 grams. So if you're finding 100 grams, it means that 100 went at 15, which is so good. But the whole point here, I'm glad to see that people have gotten the point. This is how we get to answer such questions in an exam. This is how we get to answer questions. 70. So let us make sure that in our answers, we try by all means to even include units. So 48. So let us include units, because when you just write 48 or 70, 55, they won't mark you. You need to, the question is saying what mass. So you need to be putting the, you need to be putting the units. Physics mate is, thank you, sir. Okay. I'm also humbled to see that people have turned up in numbers. So let's just make sure that we share the video. Let's make sure that we like. I know certain people just participate in a live. They don't like or share the video. I know that I know. And it is in every person. So that it is unexplainable. We can't explain. But if two of us, like, you just share, even in 3 groups. So if then these people that are watching now, I can see people, a lot of you are connected. If you can share in 3 groups, each person 3, you just share in 3 groups. But people have got their personal reasons why they don't share. So we just leave it like that. So what is okay, these are the only people that have participated. Okay, thank you so much for joining in. I think you've learned 1 or 2 things from here. So this is where we are going to end from. Don't forget to join my online lessons. For those of you that haven't joined, you can join my online lessons. And this is my number. You can get in touch with me. You can contact me on this number. On WhatsApp, you text me. So even as you are texting, you need to be direct. You text, hello, this. But when you just say, good morning, sir, how are you? Like, you specify exactly the subject wants to enroll for. So the first thing is to make you download Telegram. So the first thing, download Telegram. After downloading Telegram, that's when now you can pay, and text me the screenshot of your payment either on WhatsApp or on Telegram. But it is better you do it on Telegram, where I'm going to be very fast to reply. Thank you so much for joining in. We continue tomorrow. This is where we are going to end from. Thank you so much. Let's make sure that we share the video. Make sure that we like the video. Have a wonderful day. Thank you.